Hi folks, welcome again in Eng-Man YouTube channel. So we will continue our geoscience playlist and still about core analysis. Actually, we started this topic with Klinkenberg topic here, all right, where we did a correction for, for permeability due to Klinkenberg effect. Now we will continue the core analysis study with net overburden effect. All right, so it's very, interesting topic and quite simple actually. Hopefully we can cover this simply. All right, so often laboratory porosity measurements are done at ambient conditions without applying adequate overburden stress on the core samples, right? So this leads to erroneously high porosity and permeability values that should be corrected before using them in any reservoir engineering calculations and of course in reservoir simulation. All right. In most core analysis studies, however, some core samples are selected for porosity and permeability measurements under overburden stress or overburden effect. All right. And normally, these selected measurements are made at several values of net overburden stress or NOB and included in the report. All right. And so hopefully now we can learn something from that, where we already have the correction factor for net overburden stress, let's say from a core analysis report. And then we also have ambient porosity data. And what is the corrected porosity that we can use in our analysis and simulation? All right, so that's the idea here. And this is our case. I take this material from Dr. Ezat Goma. So he's an expert. He made a very interesting and important book for reservoir engineering. And I use the case and hopefully we can learn many things here. All right, so the case is like this. So we have a reservoir and the datum depth is at 3,550 feet. And we also know the overburden gradient, 1.03 psi per foot. And we know the reservoir pressure, all right, 1518 psig, and the fraction of reservoir pressure opposing overburden stress. All right, okay. And 0.85 is the fraction of the reservoir pressure that will oppose the overburden stress. Okay, and then we also have this very important table. And as I said before, in many core analysis report, we have this kind of information where we have some measurements that will get this correction factor for NOB for each net overburden stress. All right, stress, the unit for stress is PSI. Okay, and if we have these values, how can we use these values to predict or to correct or to get the corrected porosity here for any ambient porosity information that we have? All right, so that's the thing. And these are some formulas that must be used, can be used, very important. Porosity correction factor for net overburden is the porosity measured under overburden stress divided by porosity measured under ambient temperature. All right, so it must be below 1 because porosity in ambient condition will be greater than porosity measured under overburden. All right, because the rock will expand and the pores will expand under ambient temperature or ambient pressure. And then permeability correction factor for NOB. All right, the formula is the same with porosity, permeability measured under overburden condition divided by permeability measured under ambient condition. And then what is the net overburden? Net overburden is this. So we have this sigma, which is overburden gradient, multiplied by the reservoir depth, subtracted by this. So alpha is the fracture of reservoir pressure opposing overburden stress, and then alpha multiplied by the reservoir pressure itself. All right, so that's the formula that we will use. And so let's process this information first.